I'm Theo, together with Maxime. We are the two founders of the company Erium. We are a data science startup. We have Sebastian in the call too. He's a colleague of us, and I see a few more names, Jumana, Atua. Yeah, so there are a few colleagues here. And today we're gonna tackle the topic best practices for data analytics projects. And as you have seen and read on the description of this meetup, we will not focus on like what are the technical do's and don'ts for setting up linear regression perfectly. We tackle the big picture today. And before we're going to do the deep dive into the topics that we prepared, I'd like to learn more about your background because there are a lot of names in the audience today that I don't know. Some I know, but there are a couple of few new names. And therefore, I'd like to start with the first Paul. So if you could please, again, check out the Slido app. And there you now should see the first question. So what is your professional background? If you could just hack in, so like mechanical engineer, fixing cars and bikes, or data scientist, product manager, whatever, just type it in. Gonna give it 30 seconds to a minute. All right. Oh, wow.
Does the longest answer win?
Okay, if this is the metric. All right. So what do we have here? We have real estate agents. Wow. Data science, software engineer, mechatronic engineer, data science intern. Welcome here. Theoretical astrophysicist, working as a data scientist, sales, director of data and analytics. Okay, and again, a physicist, engineering, psychologist. Okay, very interesting. And we have got in the Zoom chat, IT project manager and electronics engineer for digital signal processing. All right. All right. Thanks a lot. So we have like a rather technical background today, but also some guys from the business side. Very good. Very good. And again, a condensation of physicists. That's scary. All right. Thanks for this feedback. This helps a lot in order to really present the stuff that you are hopefully interested in. So first of all, let me introduce to you who is talking to you here, actually. And here I've brought like not bullet points, but 4 pictures in order to illustrate what and who Erium is. So we are a bunch of data scientists and software engineers enjoying good coffee in a startup office in Garching bei München. So if you ever are on the TUM campus, feel free to reach out to us and we're going to invite you to a delicious cappuccino or espresso. And actually, and this is why this picture is the biggest one, we are at home and rooted in data science. And we learned in the past that our approach, the algorithms and the processes that we developed, that they can be abstracted and therefore scaled. And this is what we use web technology for. So we put our algorithms and processes into products nowadays. And thereby we learned a lot. And those learnings I'd like to share today. I think those numbers are pretty interesting. So we did not make them up ourselves, but if you look at the bottom left, we found these numbers at fastdatascience.com and at gartner.com. There, you get a confirmation for something that you at least feel as a data scientist, that most, and in numbers, 98% of all data science projects fail. And it's pretty interesting if you look into the details. So 85% of those projects, they fail completely in terms of the projects are not even completed or they did not complete within time. So this is also like not an acceptance criteria met there. Or in the second case, they get completed, but they fulfill the wrong metric and therefore that do not provide any business value. And only 2% they create true and real business value. And the question is why? And today's meetup should exactly tackle this question. So what are the best practices to turn those 2% up, to maybe even turn this around, to make 98% of the data science projects and initiatives a success and not a failure? And before I present our learnings, I'd like to again give you the opportunity to share your experience. I just started another poll. And let's collect the reasons why data analytics projects fail for you. So if you are not an intern, maybe, but if you have some experience, even juniors should have experienced a data science project at least being stopped.
Should we put in multiple answers?
You
or
can put
focus on
in
one?
as many answers as you like, And if you send one in, then you see the answers of the others. And if you type in the same thing again, then the names, they will be increased in size. So we will have like a word cloud. All right, we've got no stakeholder buy-in, insufficient data. We need the Jeopardy jingle. For those who joined the meeting, I shared the link in the chat again. All right, 2 participants still typing. All right, thanks a lot for sharing your experience. So if I just read out the answers out loudly. So we've got here, no clear project specification. Oh, okay, so there's a project management issue. We've got data present numbers and don't present process. Then the next one, no clear goal. Objectives not clear. Bad data collection, failed data cleaning, reluctance of managers, got distracted after the initial idea was infeasible. Project should have been stopped after 2 days. Wow. Okay. No clear business use case, no research phase, unrealistic expectations. Process was not modelable. Okay. Tech first, not strategy first. Incomplete or low quality data. Gained information is not business value. Data is not suitable for unsupervised machine learning. Insufficient data and no stakeholder buy-in. All right. There are a lot of business topics in this list, but also a couple of data science related issues. For example, the process was not modelable. I would be very interested in whoever wrote this. If you like, just turn on your mic and maybe you can explain a little bit.
Yeah, that was me.
Okay. Yeah.
So what I
Of
meant
course.
is not that it was not describable mathematically, but you could not, it from the point of data science, or from the point of view of data science, it just behaved too much like random noise. So no model could be found that predicted it accordingly, it appropriately, even though data were available. So probably the more, then the other answer would be probably that the relevant parameters were probably not part of the data, and therefore it behaved like noise.
All right, thanks for the explanation. And another one I'm specifically interested in is reluctance of managers. So whoever wrote this one, would you like, or would you be willing to share more information there? Ah, Mustafa, very nice, very nice. Thanks a lot. So my question is here specifically, so which managers exactly? So because the data science initiative, it must have come from some management. So which managers were then reluctant?
So I am the one, the intern. So actually I'm having a project at my company, but the problem is that it's a kind of an internal project, and we want to build a product. But the problem is that I'm working as a data science intern, but the managers, they are not have a lot of experience with the data science. So when we are talking with our managers, we have to translate our problem or what we want to build in another. I mean, we have to translate our purpose as a business business product. I mean, or marketing product. So I think the problem is the translation process, because we cannot make advertisement of the idea of what we are having, and we cannot create the product, because I think our idea was good or enough for creating a product, but we couldn't translate it for the managers. So the problem, I mean, the reluctance of the managers means that we couldn't translate our purpose very well. Mm-hmm. So they didn't accept our product. So we have to stop our project, and we started another one internally.
Oh, okay. Wow. Thanks for sharing. Very insightful. There is another one in there. Gained information is not business value. Was there a similar story behind that one, that it was a translation issue, or was there more into it? The one
no.
with
I meant it in regards to the 98% of failed projects. There are certainly lots of projects that where you gained something knowledge, and that is not business value out of some perspective, but actually it is, that you wouldn't try this again, for example.
Okay. That's a very good point, Thomas, because it triggers the Vietnam flashbacks that I now have, that people think that data science is like a very predictable process, and they are surprised when you say, no, we don't know before what the outcome of a certain experiment is, especially in the early phases of a data science initiative where you have an exploration phase. Then it's just a natural, or it's like the asset that you get from an experiment. It's the insight and not a software product in the very first place. So this is a very good point, because it illustrates now that this must also be clear, that data science or data analytics, it's not straight software engineering, but still this is manageable. I'm gonna show you a suggestion for that in a second. All right, so what I prepared is a short summary, also based on what those clever ladies and guys at fastdatascience.com wrote. What are the root causes of failure from their perspective? And they split it up in the business and the data science and tech section. And in the business section, so there you have got like a misalignment of interest between the teams, the business and the tech team. You've got data scientists that make clever suggestions, but the business side just does not listen to them. Communication. They do not await the return of investment, as they think, okay, let's invest some few euros now and get a return of our investment tomorrow, but maybe it takes like half a year, 2 years. They are not able to get the credit for success. So if you take a big automotive company, for example, they have the Rochade principle in their company. So they change positions every year, or the longest period for upper manager is what I got like 2 years. So if you start a data science initiative and it takes like a year to get some final results and to get the credits and the Lorbeeren, then this is maybe too late. And what they at Fast Data Science also described was that communication has broken down due to day-to-day stress. So what they mean there is that everyone is just covered in day-to-day tasks, and data science is a new, very interdisciplinary endeavor in a company. No one has time for new communication channels, and therefore keeping this project alive. So the business side is very much about communication, and the data science and tech side is, something that comes out of academia. The first point spends too much time on experiments. This is based on the freedom you have, especially when you do a PhD. There you have 3 years of time digging yourself into a topic, and in the industry reality, you just do not have the time. So experimenting is important, but you have to limit time there. Then what we also had like 5 minutes ago, the example of Mustafa. Data scientists sometimes have problems communicating their findings. The wrong metric is chosen. Also, but not the primary thing, is that the right skills are just not there. Like if you need to build an expectation maximization algorithm, but you never learned how to do that, and you just are not able to do that, you do not have the skills there, the technical skills. And something that happens or does not happen between data scientists and engineers when tackling a deep tech use case, that there is no knowledge transfer happening. And this is also something that we at Erium learned in the very early days, that you have to listen very carefully to the engineers when tackling a use case in, for example, the production industry. So you have to learn the vocabulary, and you really have to use this vocabulary so the engineers that you're talking to, that they understand you. And as a next step, I'd like to focus on the interdisciplinarity. As I just mentioned, data science and data analytics in a company is something new, not only because of the technical topic, but also because of the interdisciplinarity. And I just sketched here 4 domains, the 4 main domains that have to be included. We have the management, the domain experts, data scientists, data analysts, and of course we have the IT operations part. And here, before we dive into the details of like data science champion, I would be interested in, do you have another role in your team or in the appendix to your team with whom you have to deal very frequently? One example, just to give you a trigger, is the Betriebsrat, like the council of the employees. So I've seen it very often that also this council has a fixed table in the circle. So what do you say? Do you have more parties in your private, in your personal data science projects than just those 4? Just unmute yourself and shout in. That's not a strict classroom here. All right, then this seems to cover it pretty well. A point that I'd like to make here is the following. We already learned from what you, Mustafa, said, that this translational role is very important. And as a first key takeaway, what I'd like to communicate today is that a company should implement a dedicated person to be a data science advocate, or you could call it a data science champion, or you could call it an analytics translator. Why? Because it's so hard to keep all those parties in sync. And we even had an eMeetup just only on this topic with Afke Skouten. She only talked for 1 hour about the role of an analytics translator. And in short, like what the idea is that the analytics translator, this person, it takes a business problem, or first of all, actually a business goal, a strategic goal, then analyzes, okay, what is a business problem? If I fix this, I'm going to reach my business goal, then translates this into a data problem, or at least an analytics problem. So you can have a handover to an analytics team. And this analytics solution is then translated back into a business solution. So again, that you communicate, okay, we've now found this polynomial regression that does the job on the R2 score. Yeah, but what does this now mean for business numbers? So how does this impact our sales, our revenue, our productivity, our OEE? So this is a very important step that must not be forgotten to communicate the findings back so that management understands why it was a good idea to invest thousands and millions of euros into the analytics program. And in order to keep those parties in sync, they have to work very collaboratively. And this small word, collaboration, that you can see here on the left, this was actually one of the triggers that motivated us as Erium to build the data science platform Helerium, because we had the need that we did not have a data science platform that enabled us to bring management as well as IT, as well as the domain experts, as well as the data scientists on one table. And there I'd like to show you something in a second, namely the data strategy board that we developed in the last years. What is a data strategy? A data strategy, if you take Wikipedia, I cannot remember fully by heart, but I think it's the specification. Why do you what with your data and how, actually? And what we see is that companies do not have a data strategy at all, or they have just a rough idea, and only very few have a very structured data science and data strategy, where all the stakeholders in the interdisciplinary team, first of all, have an idea about it, agree on it, and act accordingly to it. And therefore, I'm just starting another poll because I'm very interested in how the situation is for you. So if you could again check out Slido, please. There I'd like to hand in your votes. So does your company have a data strategy? Wow, okay, one vote, and it's a very good one.
Theo, maybe to add a question to this, what is, in your opinion, a data strategy? Like, what components does this have? How comprehensive is a data strategy actually?
Yeah, we'll come to this in a second. In words, it connects the two worlds of data with business goals, and there are a few steps in between, and we're gonna check it out in a second. We've got eight votes. Is this correct? So you can see the results too, right? In the Slido?
Yes.
Very good. So fortunately, we do not have a single answer on, okay, what the fuck is even data? We have 22% yes, and it's actively used and maintained. That's very good. We have the same amount of votes, so maybe 2 votes out of 9. Yes, but it's detached from reality. And we have 5 out of 9 not even having a clue about what a data strategy is. Okay, let's have a look, as I just promised. So a data strategy connects, as I just said, 2 things. First of all, a vision and a company's strategic why with the data a company has, could have, or maybe could buy. And in between, what you have to find is business areas and processes that you'd like to tackle, that you like to make profit from data and data analytics. And how you do it then in practice is that you implement use cases. And in between, you have to, if you do it after the state of the art, you do it the following way. First of all, you start with the vision and the why. That's very important. And data analytics programs, they not rarely they reveal that companies do not have a vision at all. So because when I ask business owners, okay, what does your company even do and why? Then the answer is, yeah, we make money. And that's like the most generic answer a company in a capitalistic world could give. Yeah, every company just makes money. So sit down and answer the question. So why does your company even exist? So the good ones, they have an answer to this. And once you have the vision statement, you can align your data analytics program with the vision statement. And in order to make this specific and well worded, you, from my perspective, better use OKRs. OKRs, objectives and key results, they are a way to write down goals and metrics, how to measure if your initiatives that you started supported reaching the objective. So in the green card here, you first of all, you just write down your objectives. And in the second column, you then write down and specify specific domains and processes in your company that you'd like to tackle with data analytics. For example, if your vision is that you create toys, yeah, it's now Christmas time, very good example. You manufacture toys that are sustainably produced and do not create waste, or at least create as less waste as possible, then your objective is that you reduce the plastic waste that your company creates by as much as possible in the future. This is the objective. The key result would then be that you tackle in your production area. So this is not about HR, this is not about sales, this is about production, that you reduce waste from scrap parts by 30% within 1 year. This is clearly measurable. Yeah, this is no debating about this. Yeah, did we reach the result or no? Not. There is clearly measurable. Yeah, did we reduce the waste? Yes or no? And different business areas could be the sales department. They could use data in order to find the most promising customers, and so on and so forth. And from that, you match the data with your business areas by specifying use cases using the data. And those use cases, they have some phases. We're going to look into this in a second. But coming from the data, it's also important to make a distinction here. So data is not just data. Data, in reality, it always starts with something that is already there. Yeah. Collecting new data is expensive. So this is just also the game that you just take what you find in the company, and there you've got data sources that you can just connect to. Like in the production framework, it would be maybe that in a MES system or in a shop floor management system, you've got some data about your plastic molding machines and the scrap rates and the quality. So this would be a raw data source. And this raw data source, it can be used for a first experiment using a database dump. But in order to make a productive system, making use of this data, you must, not only because of stability issues, you have to detach the production data from your analytics framework. And what you usually do is you introduce some kinds of data aggregation platforms. This can be data warehouses, data lakes, data lakehouses. It can also be just like a Python script that does some copying and or caching. And from that, you derive a data product or multiple data products. And a data product must not be mistaken with an application that uses data. No, a data product is a curated, well-defined, and maintained set of data with a clear responsible person or department, where you always can be sure that if you use this data, it will be, yeah, as I just said, well curated, up to date, and available. So this is something that comes from actually top management and has to come from top management, because if like some shop floor engineers, if they make up something like this, the probability is pretty high that the right-hand side is correct, but the left-hand side is not in alignment with what the business owners, what they have in mind. So any questions so far? Because in the next step, I'd like to discuss how to get to this. Because it's not just drawing boxes and connecting them randomly. Any questions or remarks? All right, then let's have a look how to actually create such a data strategy. And therefore, what we prepared is a data strategy meeting agenda. And again, we use our Helerium boards for this. And there you see 3 big blocks of colors. First, a yellow part, a green main part, and a red postlude aftermath part. And how we work through this here, the idea is the following, that the individual agenda points are followed one by one from top to bottom. And I'd like to not go through each and every detail. You are very welcome to check out the data strategy meeting board on your own. If you're interested, just reach out to Maxime, Sebastian, or me. I'd like to emphasize a few things here. First of all, when setting up a data strategy meeting, prepare very well. So the most dramatic thing that can happen is that you just invite some people. You maybe even get an appointment with the CEO, the CTO, the CDO, and then you just, think, let's discuss this a little bit and bring some topics to the table. You have to prepare very well. Why? First of all, you must be very careful about who has to be invited. And I already had it in the past that you sit in a very good discussion, have a very good meeting, and then you realize, okay, we all forgot to include the IT people. And then you get stuck because you just don't know, do we have the data? In which condition is the database? Is it accessible? If yes, how high are the costs in order to get any data out of the system? So first of all, check that the stakeholders are then really attending the meeting that you need in this meeting. Then the next thing is that if this is like a second meeting, if you already have a draft for data strategy, review the data strategy before and check about the changes, because the meeting will be a mess anyways. And then third part is that you prepare the board that you can just see. So, and what do we have here? First of all, you have a review phase. And this review phase tackles all the topics that we just discussed. So first of all, looking into the past, and is it still up to date? Is the business goal and the objectives, are they still up to date? Are the business areas that shall be tackled still up to date? If yes or no, whatever the result is, take notes and agree on the results. Then review the use cases that are currently being worked on. And only after having a very, very straight assessment of what happened in the past, continue and brainstorm new ideas. Because this is something that very easily happens, that everyone just brings new ideas on the table, and then mess becomes a clusterfuck. So first of all, when you start this meeting and when you start an initiative, really make tabula rasa and evaluate what is the current status about the use cases that have been tried in the past. Then you can start collecting new ideas. And then you can start thinking about, is the data landscape sufficient in order to enable the use cases that we just imagined? Of course, this is already part in the data use case discussion. So this is one part. Do we have the data in principle, or can we buy it maybe? But then you also have to specify, okay, we now identified that we need this and this and this data product. So you have to decide to build this data product, because the data product will not build itself. And very important, and this brings me to the very first point that we discussed today, review again if the champions and partners that you have in the company, and with partners, I also explicitly mean external partners, because you don't have to reinvent the wheel for a linear regression all the time. Is it still up to date, or do you need more champions, more business translators? Do you need external partners? Are you satisfied with their performance? And those discussion results flow into the post-loop process. The data science champion, the main advocate of data science in a company, he or she is responsible for then collecting all this info and bringing it into the data strategy board again. So this is a very important part, that you not give up after the meeting and say, yeah, it was very nice talking to everyone. It was a great success. Of course, every meeting is a great success, but really do the homework afterwards. And with this process, from our experience, we are very successful, not only creating a data strategy like this from scratch, but also keeping it up to date. And what you can see here is that if you imagine that in the very beginning of a data science initiative, this happens every 2 weeks, you have a very close keeping the CDO office, like the chief data officer's office, in the loop, because this is uncomfortable, right? And we enforce this process here. So enforce yourself to talk to the CDO office very frequently. They are your friends. They give you all the money you need to conduct your data science projects. So any questions or remarks? Shall we have a look at some details here? Or is this good and shall we go on? Three, two, one. All right, and let's proceed. The next discussion topic that I'd like to dive in. This is already hands-on in use case, in use case conduction and bringing it to reality. So what we see very often is that people start very early building like full products, diving into the world of software engineering, or that they circulate for eternity into an exploration phase. And there I'd like to start another poll. So if you check Slido again, first of all, before diving into this topic, I'd like to know from you, at which phase do you introduce MLOps and tracking, like ML flow or similar packages? Maybe you could share your insights there. So we have from the very beginning, when building prototypes, when creating products, not at all, or what the heck is MLOps? All right, 8 votes already. So what do we have so far? We've got 1 vote from the very beginning, like already in experimentation phase, 0 votes when building prototypes. Then we have got 2 votes for when creating products, 1 vote not at all, and 5 votes. What is even MLOps all about?
I would be very interested in maybe the people that answered from the beginning. How do you do it in practice? Because things are so difficult to compare if you try completely different things. So maybe one of you wants to elaborate on this. I would be very curious.
So this was a single vote.
Okay, so then no distributed responsibility.
Yeah. All right. If you don't want to share,
all right.
No problem at all. So that's really interesting. So surprising for me, as I think MLOps hits marketing a lot. So MLOps, with a few words, it's about operationalizing data products. So bringing them from a prototypical state to something that is very stable, and where you also define when is a retraining be done, where are the models deployed, where is or how does the surveillance work? Is the model still accurate? Has it to be retrained? So this is MLOps. And what we see is that it's maybe an idea to not start with it from the very, very beginning, as it introduces a lot of complexity for most use cases. But still, of course, as always, there are cases where it perfectly makes sense to use them from the very beginning. But if the data strategies is rather new in a company, from what we learned, it's a good idea to, first of all, delay the introduction of MLOps. So what are the phases that we use in our projects? We separate individual use case classes into 3 steps. The first one is an exploration phase. Then we go into a prototyping phase, and then we create specific products where we then apply MLOps tooling. And what we learned is that the separation is really important, as the goals are very different from phase to phase. And if we have a look at Erium workspace, where we use the structure, there you can see that we use a project management board in order to keep track of a certain use case idea. And it's like a more in detail description of a use case compared to only the single card that we have on the data strategy board. But again, it's very goal driven. Like, you specify your analytics goals, your project setup, and also describe how the implementation works. And then what we have down here is individual ideas, prototypes, and products that live in this world of this use case, and they populate and enable each other. And what we use here on the left is also like a folder structure that is clearly separated between those 3 phases. And the folder structure, it's not just a duplication of everything over and over again, but the exploration phase, it's very, very hypothesis testing driven. So we have the exploration board. The structure that we define is really, really simple. It only contains yellow cards for domain knowledge, ideas, experiments, findings. And in this exploration, there you use Jupyter notebooks. You are allowed to mess around to find some findings that enable you to say, okay, we've got now a prototype idea that makes sense to invest more effort into it. And once you identified such a prototype, you create a card here and link it to the prototype folder in your prototype section. And there we introduce, for example, a Python module. So no Python modularization in the exploration phase. This would be, from our perspective, overkill. And what we also have for the prototype, but not for the exploration phase, is a prototype description board, like a business model canvas just for products, where you clearly specify how does the product work and how does it create business value, and with which KPIs is it measured. And if we remember those issues here, that the data scientists chase the wrong metric, this is our answer to this problem. With this board, we enforce that everyone has on its mind, his or her mind, what is the business benefit, what is the user benefit that we'd like to reach, how is it measured, and how does the model really pay into the target KPI. Let me jump back. Yeah, that's a screenshot. And as a final remark, I'd like to make my third most important statement today. It's the one that you have to tackle processes instead of just use cases. So what do I mean by that? When I hear about data science initiatives in companies, they very often are what we call the second phase here. So this is not like a use case phase diagram. This is like the data analytics strategy of a company as a whole. And 3, 4, 5 people are hired in order to do data science. And they just do use cases with maybe more or less success. But what we see is that by this, they just, they only solve very, very, very isolated problems, but they do not have a big business impact. Why? Because they do not tackle the processes of a company. But this is what digital transformation is all about, to change and improve the processes within a company to make value from data. And this slide was drawn in order to communicate this idea that, of course, it's important to conduct use cases, but you have to embed them in a data strategy where one day as a kickoff is even enough in order to guide those use cases in a reasonable direction. And then you have to make a transition, a stabilization phase, where from this small team with 3, 4, 5 data scientists, you enable a bigger group of employees and of a company to make use of data analytics. And then, after 2 years, you maybe have data products, data product-driven revenue creation. And this is the mastery level. But reaching this stabilization phase, many companies just miss. And what's really crucial there is that you have something to review and check, so that not only this can be used in everyday life from a very, very beginning, it also always needs to be reviewable what you produce, especially when you are deep dived data scientist. Always make it reviewable and understandable what you do to business people, to managers. And this learning was what brought us to the feature in Erium, that we not only created templates for various use case categories in order to improve the speed of prototyping, we also included, for every use case where it makes sense, for example, like a linear regression example, we introduced Streamlit apps in order to make it tangible, to get a feeling for what are you working on. And this is something that I only can recommend, that if you create a prototype, if you have an idea, invest like half a day, build a Streamlit application that enables your teammates to play around with some sliders. So what you can see here is like the prediction, what is your diabetes risk, depending on like stuff, your age, your body mass index, and some health markers in the blood. And this is really fun playing around with. So you see age, the impact of age is not that big, but boy, I should hit the gym again. So if I check out this, all right. So you get the point, right? So make this tangible. That are the main learnings that we prepared for today. Thanks for your attention. And we have a few more minutes left. We are not in a hurry. So if you'd like to share how you manage data analytics in your company, if you have some experience, fun stories, or insights to share, I'm very looking forward to hearing them. Thanks a lot. All right, silent applause. Thanks, Lena.
I also always like these the stories of when it wasn't done like this and completely went bonkers. So when then a project that seemed so simple took 5 years or something, okay, maybe not 5, but 3 years. I mean, many have witnessed something like this.
So Theo, maybe a question from my side. We've come across this repeatedly, that also in this discussion, that the data team sometimes struggles to communicate well with management and with other stakeholders. Now, from your experience, what are ways to mitigate this? What are ways to do it better? How are there any techniques or ways to go about communicating with manager, with a subject matter expert, with IT maybe? What do you do there?
So what helps is to give the management a place to look it up and to, as a data analyst, write it down. Because it's very often just forgotten. It's so simple, right? You've got some results, and for you it's clear, like an R2 score. Yeah. This means a lot to you as a data scientist. But what does this actually mean for the business goal of a use case? And then you don't write it down, or you write it down in your personal notes. And both is not accessible to the management. And this is the reason why we introduced those interdisciplinary boards in Erium, where the business team members can just check out the green cards here if they like to have the technical findings, but they don't have to struggle with an implementation and code here. They can just ignore it. They can just focus on the green cards. Or if you'd like to go up one level, you dive into the data strategy and you just check out, okay, what is the use case specification here? And that's not hard. It's just inconvenient to do. And so what we did is we prepared as well as structure to make it as easy as possible for a data scientist to just write down those findings. It's not that big of a deal.
It takes a little bit of discipline, though, I have to admit. Sometimes to, I just want to do the next experiment. I have 5 ideas. I want to do them, code them immediately, right? And
but it takes also some discipline to not eat all chocolate Christmas thingies that
I never said that I was good at that. Yeah, exactly. It's exactly the same thing, right? Because you as a data scientist, you always have another idea that you want to try, and then you might have to leave at some point and did not write down anything, and then nobody can follow what you did, not even yourself. Sometimes 2 days later. So maybe we have a couple of questions in the Slido.
Ah, nice. So first one. I've got 2 questions. First, how should we organize our data for best practice of data strategy, data warehouses, lakes, or separating all data sources? The lawyer's answer, it depends. Yeah, it really depends on what your data products look like that you'd like to build in order to facilitate and enable your use cases. So if data is a very big part of your company, like an e-commerce business, then you will have a different data aggregation platform compared to a small, mainly manufacturing company that only uses like small tables of maybe 1 megabyte a day that shall be processed by a Raspberry Pi.
I would add to that, make them, the first step is that you make them available for for POCs, for proof of concept. You need to facilitate those in the first step. And then once you get to prototypes or products, it will come to you what kind of product you need, what kind of data product. But the important thing is that you make it accessible in the first place so that you can do these POCs, because then it will be more concrete. That would be my take on it.
Yeah, definitely.
And the second is on how frequently to do these data strategy meetings, right?
Yeah, in the very first, very frequently. So if you stick to this implementation model of a data strategy in a company, so it's the very start of everything. There you have a full day meeting, then everybody is mind blown. Then in the first use cases, there you have to meet once a week, and then you fade down. You switch when you have the impression, okay, once a week is too often. Then you decide on going to once every 2 weeks. Then you can decide to do it once every 4 weeks, but it must never be less than once per quarter. So this is like the lowest limit from our experience. So once every 3 months, you should have this data strategy meeting at least.
So maybe one one comment from my side, I've worked on transformation projects and innovation projects quite a while. A good way to go about involving management is always to keep in mind that they are there to make decisions. They're not there to review and share your thoughts and like what you did. They're simply there to make decisions. And the less they have to read, the less time they have to spend to get to a point where they can actually make a decision, the better it is for corporate management. And the more likely you are to have their attention on the things that you think are important. So what I used to do with my teams is when we prepared such meetings, we set them up in two parts. One was the internal review. What have we done? What can we sort out internally? And then there was a second part, maybe the last half hour of the meeting or of the day, where we put the things we actually needed management to decide upon on the table. And it's very important to not waste management's time. Otherwise, the best thing that can happen to you actually is you lose their attention and they decline to come. So good practices, discuss all the internals, what you have to do, what's relevant for the team, but not for management, what's not decision relevant first, and then use the last hour, maybe half an hour, lay out the situation very clearly, very concisely. What is the problem? What options do we have? Always give options. Never just lay a problem on the table and tell management, now your call, what shall we do? Not working. Put a couple of alternatives on the table. What could we do to solve this? And then let management decide. And actually very important is also what Theo mentioned earlier, act upon this meeting. So
that's the most important card here.
Do not simply note what management had to say and what they decided. Show them action quickly. So that is some experience from big companies, how they do it. Very important. Also for data science projects.
We have 3 more remarks in the Slido section. I'd like to share also in a big round. So keep it short and simple. Yeah, that's definitely a good advice. It would be easier to show and discuss with management if it's possible to have more examples of data science examples as Streamlit applications. Yes, that's the reason why we included like Streamlit demo applications for all the stuff that is templated here. I couldn't agree more. And management is always interested to how much is the investment, what is the outcome. That's also very true because that's their business in the end. And therefore, I can only recommend, if you'd like to discuss this further, that we have a deep dive together how you keep those 2 sides on track in a data science project. Yeah, so in terms of keep it short and simple, we've got 6 minutes past 5. Let's conclude this eMeetup. Thanks a lot for the attention and see you next time. Bye-bye.